Oh, I didn't know.
getting some good audio. Okay, so yes, we can come out of it. Thank you.
Check, check, 1, 2, check. Check, check, 1, 2. Check, check, 1, 2. Check, check. Check, 2, check, check. Check, 1, 2, check.
We have an emergency.
Good morning, everyone. I think when I thought about 6 minutes after 9, so I
I'm sorry?
In the spirit of reconciliation, I wish to acknowledge that McMaster sits on the traditional territory of the Mississauga and Haudenosaunee nations, and within lands protected by the District 116 conflict. This acknowledgement reminds us to use the land effectively, to take what we need, to leave what we can, and to keep the dish clean for the people coming after us. My name is Cindy Lewis, and I have the great honor of serving as McMaster University of Lisbon. But today I have 2 other very special honors. First, I have the honor to welcome you to the Lewis and Bruce Sherman Center for Digital Scholarship. This space, which opened in December 2012, supports consulting and technical support to graduate students and faculty engaged in new and technology-infused models of research. And second, I have the honor to open Common Challenges and Shared Solutions, the 2018 McMaster Research Data Forum. This event has actually been the brainchild of Jay Berger, right over there. Jay is our newly appointed Administrative Director of the Sherman Center and the Associate Director of Digital Scholarship Services here at the University Library. And Jay is also the Chair of our campus's new Research Data Management Committee. But the journey is not unique to McMaster, hence the title Common Challenges, Shared Solutions. And hence our desire to have colleagues from other universities join us this morning, and welcome to all of you here today. Now, I think many of us in this room have been haunted by issues associated with the effective management of data for many, many years. But we really sat up and took notice around October 2013 when the tri-agencies released Capitalizing on Big Data, a public consultation on digital scholarship. And institutions around the country, including McMaster, submitted comments and attended stakeholder meetings. And the issue seemed so complex and so culturally insurmountable. And many players have emerged in the landscape. We'll hear a lot today about the Portage Network, which was launched in 2015 by the Canadian Association of Research Libraries to develop a national research data culture. And we'll hear from individuals around campus who have a clear stake in finding the best solutions. Faculty members actively engaged in data-intensive work, colleagues in high-performance computing, etc. And the timing of this conversation is excellent. We're sitting on the precipice of the tri-agency's new policy released for public consultation in fall 2018. And that new policy will impose new expectations for how campuses and how individual researchers manage the data that we collect. And the challenges are common, and the best solutions undoubtedly will be shared. So I'm going to talk
being told I need to grab a microphone so our friends online can hear as well. So, all right. Okay, well, thank you, Vivian, and thank you, everyone, for showing up for this event. This is something that's been in the works or in the thoughts anyway for quite a long time. And a lot of this springs out of the work that we do here in the library, speaking with different support units and speaking with researchers as well. And understanding that across campus, everyone struggles in one way or another with managing their data. And sometimes those struggles are similar, and sometimes those struggles are very different. But there's a lot to be gained just by speaking to each other and starting a conversation. And this is what we hope that today can really help start. So Vivian did a fantastic job of contextualizing why we're here in the bigger processes at work. So I won't spend too much time to talk about that. Before I get going, just want to clear up the most important housekeeping part of the day, which is where are the washrooms. So if you walk out the doors here, if you take a left, down at the end of the hallway, you'll find the washrooms there. Okay. So before we start with our formal program here, with our panel discussion and keynote speaker, I want to take a moment and just define some terms so that we're on relatively the same page. And so these two terms have been taken from pretty commonly accepted definitions. So when we're talking about research data, the Tri-Agency defines research data as contents that are used as primary sources to support research, scholarship, artistic activities, or research creation, and that are used as evidence in the research process and commonly accepted in the research community as necessary to validate research findings and results. So it's a very broad definition of what constitutes research data, and it's broader than maybe some of the fields and disciplines that we think about when we think about data itself. It also brings in these ideas of validation of research results, and this is an important part that the tri-agencies are interested in. So then research data management, one definition, which is from Casare, refers to the storage, access, and preservation of data produced from a given investigation. Data management processes or practices cover the entire life cycle of the data and include a number of different activities, including file naming, data quality control, quality assurance, data access, data documentation, et cetera, et cetera. And so put very simply, the way we like to frame this is that research data management is active organization and maintenance of data throughout the entire research lifecycle. So from the time of inception of a research project to the end of the research project and depositing of those materials somewhere where others or yourself at some point in the future can find, access, and reuse those materials. So the interest that comes from the federal government and the tri-agencies are interests that should be shared by all of us, really, in that applying best practices for managing data have benefits to many groups around campus. And so for researchers and their collaborators, it improves the efficiency of their work, provides extra credit for those research work when those shared data sets become a citable object, increases research impact, so there's studies showing in certain disciplines now that publications that link to data are more cited, and can help meet funding requirements. And this is something that we'll speak more about today. So for research communities, their interest is that this accelerates discovery. When data can be shared and reused by other people, this should, in theory, increase the usability and the amount of data that's available to researchers. And finally, the funders and the public in general are interested in increased return on investment. So if we can create this ecosystem where data can be reshared and reused by others, this ultimately increases the return on investment for public funds that are used to sponsor research. And then data can be viewed as a public good in that context. And so Vivian mentioned some of the guidance documents and policy documents that have led up to where we are now. And so I'm going to just highlight on the Tri-Agency Statement of Principles on Digital Data Management, which came out a few years ago now. What this document does is really lays out the expectations that the tri-agencies have for data management within research projects. And so all different types of activities, from planning to creating appropriate metadata, to understanding the constraints and obligations with that data as well. And that may preclude sharing, for example, to be mindful of any ethical or commercial limitations on that as well. Doing this in a timely manner, collecting and storing this data appropriately, making sure that acknowledgement and citation happens when those products are reused, and of course do this as efficiently and as cost effective as possible, please. So, and this document also outlines the responsibilities. So this isn't just a responsibility on the researcher. This document outlines the various stakeholders that are responsible for supporting this as well. So it's not just a burden that the researchers need to bear, it's something that the support units for this research need to help the researchers work through. And so there are, I won't summarize or I won't go over this slide, but just to say that everyone involved in the research enterprise has a role to play in this. And so finally, I won't take too long to talk about this either, but this is part of the proceedings of the panel discussion that we're going to have in a minute. And Jeff Moon, in our keynote after that, is going to talk about this a little bit more as well, is the Tri-Agency Draft Data Management Policy, which was released in June of 2018. And really this lays out what will become of a mandate or a policy for data management. And what we know right now, we don't know what the final language is going to look like, but we know more or less there's going to be 3 pillars. So institutions are going to be required to create an institutional strategy to explain how they are going to provide the support for researchers to meet the rest of the requirements. Researchers will be required in some or all cases to create research data management plans that outlines their plan for managing the data from inception to final deposit. And then there's some language around data deposit. We don't know exactly how that'll work out. But what we do know is that there will be strong recommendation or requirement for researchers to deposit data that allows for verification of results at the end, being mindful of situations where data can't be shared publicly. And so I hope that gives you a bit more context of what's going on at a large scale and why we thought it was important to have this event today. And so this brings us to our formal part of the program. And so we have 2 sessions in the morning. And the first session is an invited panel where we have 5 panelists asked to come up. And these panelists represent researchers and research managers that are working in very different disciplines and very different contexts. And we hope through this panel discussion we can start to expose some of these common challenges that people face and then get to the point of talking about shared solutions as well. And so following that, Jeff Moon from the Portage Network will be coming in after the break to give a keynote lecture and tell us about what's happening at a larger scale and how all these pieces fit together within an institution. To come up to the front here, grab a seat, and then we'll get going. Okay, so I'm going to do a quick introduction here, and then we'll show you the questions that were posed as homework to these panelists that we're going to work through here. So, starting at your far right, and I'll work my way left here. So, Dr. Lawrence Grierson is associate professor, Department of Family Medicine, and an education research scientist with McMaster's Faculty Health Science Program for Education Research, Innovation, and Theory, also known as Merit. He also serves as Assistant Dean, Health Sciences Education Graduate Program, and as an education scientist in the undergraduate MD program in the Michael G. DeGroote School of Medicine and the McMaster Community and Rural Education Program, MacCare. So to your left there, Dr. Antonio Paez is professor in the School of Geography and Sciences at McMaster University. His recent work and research includes studies on accessibility, spatial filtering, aging and mobility, spatial analysis of qualitative variables, transportation and social exclusion, influence of built and social environments on travel behavior, social networks and decision-making, telework adoption, and blood donor behavior and trends. So a wide range of research that kind of touches on data and on social issues as well. So Dr. Paez is published widely and is an author of over 50 papers, many appearing in leading international journals. And continuing on here, Krisha Dukac is the McMaster Data Manager for the Global Water Futures Program, which is a large multi-university initiative funded by the Canada First Research Excellence Fund. So Krisha has a BA and MBA from McMaster, along with other information management and geographical information system certifications. Prior to her return back here to McMaster, Krisha held public and private sector positions related to information systems, including Esri at their California head office, Environment Canada in the city of Ottawa. Krisha has broad experience in data and information management and has recently become aware of the many challenges university researchers face in an era of open data and new federal government guidelines. And then moving over here, Dr. Ronald Sonodara is Director of Research and High Performance Computing Support and Special Advisor to VP Research here at McMaster. He is a neuroscientist by training with a special interest in how we learn complex skills. And he works primarily with health professionals, musicians, and athletes, though his work generalizes to many other domains. And so Ronald's work Ronald wears many hats in this university sometimes, so it's interesting to have his perspective, or many perspectives, up here. And so finally, Dr. Mike Veal is Professor of Economics at McMaster. He is the editor of the Canadian Public Policy Journal, as well as Academic Director, McMaster Statistics Canada Research Data Center, or RDC, and Principal Investigator of SSHRC, CIHR, and CFI grants associated with Canadian Research Data Center Network. And so that is our panel. And so as you can tell by those bios, we have a broad, diverse array of presenters here. And so now I will reveal to you the questions that we posed to them. And so the way that we're going to work this panel discussion is we've asked each presenter to prepare up to 5-minute response to each of these questions. So I'm going to go over these questions, and then we'll start to work our way through them. So the first question was, briefly describe a research project that you are currently undertaking. How are you managing data for that project, and what are the biggest data-related challenges that you face? And I think I'll pause it there, and then we will open it up to everyone. So we didn't really establish an order here, so we're kind of doing this on the fly. Lawrence, how do you feel about going first, and we'll just work our way across?
Sure. I guess I've forwarded some slides to you, so I'm wondering how that's integrated in, and I don't know if I've broken them up in a way that makes sense for jumping around the questions. It might be easier just to answer the question without the slides. Is that?
I'm going to leave it up to you. So I'm happy to drive this thing, and so I can bring your slides up. You can tell me to advance them. You can tell me just to turn them off.
Okay. Well, we'll leave them there, and then we'll go from there. So we've heard about, at the beginning of the preamble here, we've heard about how we're managing data on campus. The project that I'm currently engaged in really deals with managing data across campuses and across institutions, and the way we come to share and collate data that may or may not be sensitive for various institutions and people involved. There is a sort of assumed causal chain in medical education that the quality of our admissions processes and the quality of our education processes will lead to better physicians, and that these physicians will lead to better sort of healthcare delivery, and better healthcare delivery will eventually lead to patient outcomes. But there's little evidence to support that this link between education and patient health outcomes exists beyond sort of our anecdotal experiences with these sorts of things. So we formed a research consortium provincially to try to bring together various forms of data at the level of medical school admissions, medical school training, so assessments about how students do through our programs, and then to match that with their performances on college certification exams, either that the Canadian College of Family Physicians or the Royal College of Physicians and Surgeons of Canada, and the Medical Council of Canada licensing exams that students write at the end of medical school. This consortium brings its own this project brings its own challenges in terms of how do we bring this data together in a way that protects the students and the students' interests in with respect to their data and how we're using it and the type of research questions that we're asking, but also the institutions and how they're protected in terms of the way the research plays out in the press or in the literature and other places. We want to avoid situations where we're exposing individual students. It's not part of our research question. But you can imagine the concerned patient might wanting to know specific things about their doctor. And we're also trying to avoid situations where our research amounts to, we do it better at McMaster than at University of Toronto, or we do, but that's not what we're going to do with our research. So these have been sort of the biggest challenges that we've been facing. we've really been dealing with coming to terms with the nature of our partnership and the nature of our collaboration and how we're mediating and brokering the exchange of data. And from multiple sources. So we're dealing with the Council of Ontario Faculties of Medicine, which is sort of an informal or ad hoc group of the deans of the medical schools, and they break out on 3 levels at Medical Admissions Council or Committee that deals with just the data that's available through OMSAS, which is the center which mediates all of the university admissions. I'm sure many of you are familiar with that. The UE COFM, which is the deans of all the undergraduate schools, and they have sort of stake in the undergraduate data, how students perform on OSCEs or personal progress tests or in their courses, and then in postgraduate, how students perform in residency and the assessments that attend to that. We also have partners at the Medical Council of Canada who are providing licensing scores for matching. And this is sort of a challenge, and it's been a long sort of circuitous road to come to sort of favorable agreements that protect all of the interests involved, but also give us a fair amount of utility with the data that we're using. So in many ways, my role as the investigator here has moved away from being a researcher and more into a relationship broker and going around and trying to cut these deals. How am I doing for time here?
You got a couple minutes.
Yeah. Our solution for this issue so far has really been to coordinate our efforts with an entity on campus, and this will come up again when I answer question 3. That entity is the Ontario Physician Human Resource Data Center, or OFRDIC, which is like a terrible acronym, or the OPHRDC, which is sort of the long way to say it. And this is an organization that manages the Health Physician Registry for the province and is really involved in a lot of health human resource planning. So is backed and supported by the ministry and the College of Ontario Universities. And they already have extant agreements for data management with a number of entities, including the institutions at undergraduate and postgraduate, CARMS, which is the Canadian Residency Matching Service, and a whole bunch of entities. The colleges as well put their data in there also. So what we've been able to do is form a partnership that seeks to extend their mandate from beyond just stewardship of data for the purposes of health human resources to include instrumental research questions as well. And we've been working through that network of agreements to give everybody sufficient confidence that data won't only be managed and held in an appropriate way, but also the types of research questions that we're asking can be vetted and approved by a governance committee of stakeholders that is engaged through that data center. I think I'll just leave it there, and I'll come back to more on that when we get to question 3.
Great, thank you. Antonio.
Yes, thanks. And I sent a slide. So just one slide, no text, just a diagram to illustrate some of the things that I'm interested in at the moment. I would say that when Jason invited me to be part of this panel, I started reflecting on my days as a graduate student, and that was only about 20 years ago, but it feels like it was a long, long time ago. At the time, and this was not that long ago, data was, data sets were very expensive. They were, not within easy reach of everyone. If you had data set and people came and asked, can I use it? It was like, go away, mine. So 20 years on, it feels almost like, I was a cloistered monk with something very precious that I had to protect because I was learning from it. Just in the past couple of decades, we have seen a sea of change in terms of that. We have moved from that environment where even researchers will have some struggles to find data, and where sharing was not, as common because it was such a valuable resource. To a situation where we basically are in an extremely data-rich environment, I think that if we survive this century, that digital data are probably going to see. I mean, the digitalization of data is probably going to see something similar to the press for the printed word. Something that books were super valuable resources, but then once that you could replicate them easily, they just led to a revolution. Data, I think, will be seen in the same way that we had data that started to become more easily available, mainly because of it's easier to collect, but it's also easier to maintain, to share, and we have a lot more of it that it will actually be seen as a similar revolution. So thinking about that and thinking how we now live in what can fairly be described as a data-rich environment, the things that I'm interested in, and as you probably gather from my bio sketch, a lot of my work has to do with data. I'm basically an overqualified data analyst. Data touches upon almost every aspect of my research interests. But what I'm showing here on this slide is more of a something that is an overarching interest. As I have become more interested in, yes, we do all this data analysis, how can we move to make a lot of the data that we have access to, which is still expensive to collect. I mean, we do have more of it, but it's still very expensive to collect. How can we make it, more accessible and useful to a broader audience? So what that illustrates is, all the things that we have, and I became interested in this because of, some of the data sets that we have available locally, such as the travel surveys that are conducted for the region. I'm a transportation researcher as well, so the travel surveys that we have for the region, which are surveys with interviews of tens of thousands of individuals, very rich and so on and so forth, and how those data are kept in a logbox. We have all these fantastically rich information that is essentially used by a very small number of people in the region and around the world who understand what the data are, the semantics of the data, and who are sufficiently trained to be able to do queries and organize and so on with all this data. And essentially, we send the rest to a logbox where no one can see it. The reason for the logbox, there are legitimate reasons for that. Travel data tends to be very sensitive from a privacy perspective. Basically, a travel survey tells you where people live, where they go, how they travel, when they travel, and things like that. So, you don't want that to be in the public domain. So there are some legitimate reasons for doing that. But even with the efforts that have been made in terms of sharing that with the public more widely, what we have is data explorers and data retrieval systems that are extremely cumbersome to use. It's something that even an expert like myself, who's been working for years with such data sets, has a hard time going through the 7 steps of finally getting to a table with thousands of records that yet needs to be analyzed, right? So expecting anyone from the public, even if we make those, accessible through data retrieval systems and data explorers, we cannot expect every single person to have a data science degree to actually make use of all that information. So the situation where we are is that even though we have all those valuable, expensive data sets, they tend to go to the hands of experts who communicate in a language that could as well be Martian, but that other experts can read. That sometimes goes to static reports that a few people will read, as we face the pressure to publish scholarly and so on and so forth, and then provide something that is not a happy solution when trying to make that available to the public. So what I'm interested in is whether there are different ways in which we could make those data accessible to the public in a way that will be more beneficial. Whether we could make also some of those reports more attractive, more dynamic. And what I think we're seeing is a sort of convergence in terms of the technologies that we use to write and present information and the technologies that we use to disseminate information. For instance, dashboarding technologies that essentially can help us, I think, to bypass the logbox by ensuring that good data analysis practices are coded in an interface that then someone who doesn't have a data science degree can actually interact with and make sense of all the information that, that we have there. My overarching interest at the moment is how do we make all those data that have the potential to revolutionize you know, how we interact with each other, with governments, with the private sector, and so on and so forth, in a way that actually people can benefit from it. The way I see this, it's almost like, you know, again, in the Middle Ages, books will be put in libraries and will be closely guarded places where just a few had access to, you know, libraries that are open to pretty much everyone. So I think that what we need to do is find ways, technologies, techniques, strategies to make the same thing happen now with data, so that, you know, people who didn't know to read because there were no books now had the opportunity. Now data literacy is going to be the next frontier in terms of you know, public education, I think. So
Great.
I'll stop there.
Thanks, Antonio. All right, Krisha.
All right. Sorry about this slide. It's a little messy when it comes up. Oh,
It'll take a second. There we go.
so I think I'm kind of a bit of an odd person out here on the panel because I'm not a principal investigator. I'm not a researcher. So I'm just going to take you a little bit higher up, I think, in terms of our discussion. My role is as a data manager at McMaster University, but I'm part of the Global Water Futures program. And the Global Water Futures program is a multi-institutional program that is run out of the University of Saskatchewan. There are 4 partner institutions: the University of Saskatchewan, McMaster University, Wilfrid Laurier, and Waterloo. We are interested in water and protecting that. At McMaster University, we have 5 projects that are led out of our university. They are run by people in different faculties and departments. That include geography and earth science, Indigenous studies, health science, engineering, biology, and anthropology. And there's also an interaction. So we've got our projects, but we also have collaborators that basically cross from all of the different institutions, other external institutions, as well as are run out of stakeholders from the government, from various nonprofits, from industry. Jay, could I ask you to switch the slide?
Of course.
Thank you. So in essence, we have 33 projects across our program. We've also got another 7 that are coming on board. The challenges that I encounter in our program are data diversity. So we've got a vast amount of data. We've got hydrological data and atmospheric data, climate data that people have been collecting under different funding structures and sources for decades. We also have newly developed data that is being generated by GWF projects, but it is based on, a lot of it's based on previous work. And so if we look at the different types of data that we're working with, we have observational data, both collected through telemetry and instrumentation. We have observational data that people are in the field collecting. We're also doing a lot of work in remotely sensed data, drones, satellites, LiDAR. We have lab work that's going on. And then something that I think is new, perhaps more of a foreign concept with where the water, typical hydrology is coming from, is that we're now moving into health-related issues, so surveys and human subjects, as well as a lot of indigenous knowledge, which has an entirely different perspective. So now you're looking at OCAP, the ownership, control, access, and possession. That's part of the indigenous treatment of data. We've got a lot of the ethics-related issues with the human subjects in surveys. And then I think Lawrence alluded to, the fact that he's working in multiple institutions as well, and that's something else. So in terms of IT, we have researchers who are used to using a certain application. They're working in their university or institution ecosystem in terms of technology. So everyone's using a different survey tool. Some people are using Excel. Some people have a SQL database. Some people, so like the variety in terms of skills and in terms of how data is being stored is a challenge. The requirements, so in terms of how we handle data, we have a Compute Canada allocation of petabytes of data, lots of core hours for processing. So we've got big data sets, modeling data sets that are being run on the research computers, which is a complex situation. We also have the indigenous knowledge and data that we're in partnership collecting, and the human data, which requires and is complex in its own way, in that it has to be protected and that there are sensitivities. And so we're dealing with technological challenges. We've got management challenges. So that's basically, I think if I were to sum it up in one word, I would say the variety of the data, like just the variety of everything is the biggest challenge. And then carrying on, again, looking at variety, is the people. There's there's a lot of talk about reproducible research, and you should script your data processing, and that's not accessible for everybody. A lot of people are researchers. Their research interest is what they're passionate about. They're not necessarily passionate about developing R skills or MATLAB, and so to ask people to kind of move in that direction is an unknown, and it's kind of scary for them. There are differing resources amongst researchers. So some people have a really well-funded lab with lots of computing power, lots of access to like technological resources. Some labs don't have, or some researchers don't have the funding to pay for servers, and their Dropbox and Amazon Cloud are so accessible. Their students know how to use it. They say, hey, look, just all you have to do is plop it up there. But whether or not that's proper storage is kind of something that needs to be addressed. And then I think Vivian, in her introduction, mentioned the word culture, and as well, I think Antonio was talking about kind of the protecting data and the possessiveness of researchers. In particular, we have a lot of field researchers, and field research requires thousands of dollars, a lot of time to go and collect data. For instance, one of our researchers was talking about how they went up to the Northwest Territories. They spent $40,000 to get 5 people up there for 5 days. So it's an extremely expensive endeavor. I've also heard stories, one researcher telling me that, you know, her instrument went down Christmas Eve. She was out in the, like, fixing her instrument on Christmas Eve with her 6-year-old. You know, so these people are like, you know, collecting environmental data is, you know, if you miss it, it's gone. It's not like you can recapture it. And so people are very possessive, and people have been, you know, burned by colleagues that they shared data with. So there is that cultural moving from their, you know, control over their data to putting it out there is a very daunting endeavor for them to get their head around. And then lastly, so the actionable policy is my next and last topic. So we have a data policy, and it's, you know, open data, research data management plans. It's in there. It's not very easily, kind of getting everyone to swim in the same direction is difficult. The infrastructure to support people isn't where it should be. So basically finding tools with the technology, there's a lot of isolation. So we have researchers here at MAC who have their data, and it's difficult to find an easy place for them to store their data securely and allow external people to have access. Maybe you need a MAC ID. And MAC is not you know, alone in this. It's similar at other institutions. They've got, and for good reason, you know, there's security issues. So so there's that kind of hurdle where our institutions are built to look at data, you know, to kind of serve the internal group, research group, not necessarily to provide support for the, you know, global or external collaborations that are really where a lot of this is going. And then the assessment of adherence is also difficult with a lot of the policies, and it's difficult to move from the kind of aspiration to implementation. So it's those are things that we're struggling with our own policy that is somewhat reflected, is a reflection of this type of policy. So those are our topics. Yes. Thank you, Jay.
Okay. Thanks, Krisha. Ronald, I think you just go on this one by yourself.
Yeah,
right?
I'm kind of
Okay.
winging this one.
All right, excellent.
So I'm going to pull us back down into the weeds. So Jay mentioned that I have a number of different hats, and he didn't mention, but I'm terrible at following instructions. So instead of talking about one project, I'm going to talk about 3 different projects quickly. And they're 3 different projects that span different hats that I wear, and that all have slightly different challenges associated with data. Yeah, someone's locked out. If somebody could open the door, that'd be lovely. So the first hat that I'm going to put on is as one of the directors of the Live Lab. So the Live Lab at MAC is basically a 100-person room that's been built to study how people interact with each other. And it's a unique facility in the world in that it allows you to measure brainwave activity from about 20 people at a time. And there's nowhere else in the world that can do this. One of the research questions that my group is interested in is how can we take what we know about the brain, what's happening with technology, and use that to improve the way that we deliver education. And so one of the problems is that a lot of people will sit in a room like this with a PowerPoint slide up, with a bunch of boring people sitting in front of you talking at you. And although you get 3 really interesting people, by the time you get to me, people are starting to tune out. Right? And you're not really paying attention. And so one of the questions that I'm interested in is how can we start to provide cues to instructors so that when people are stopping paying attention, they know to stand up and make people jump around and that kind of work. And so we ran a study in the Live Lab to do this. And so what we did was we had a bunch of people sort of sit in a classroom setting, and we had them sit through a couple of lectures. And while they're in these lectures, we looked at, could we measure brainwave activity, At the same time, can we measure some behavioral markers that just ask them if they're paying attention or not? And then can we start to correlate these things? So that's the basic study. Comes with a whole bunch of interesting challenges, the first of which is that, as I mentioned, the Live Lab is unique. There is nowhere else in the world that lets you collect data from 20 people at the same time, brainwave data from 20 people at the same time. So there are a whole bunch of issues around that, one of which is how do you stop people from electrocuting each other? And so I'm not sort of going to get into the weeds on the technology stuff, but in terms of just how do you even collect this kind of data, there's a whole set of data challenges and physics challenges that you have to overcome to do that. And then when you have all this data that's coming in, EEG data is huge. You're measuring thousands of data points a second for an hour-long lecture from 20 people at the same time. That's a vast amount of data. That has to be split across a bunch of different computers because you can't collect that much data on a single computer. The kind of phenomenon that we're measuring, a difference of a millisecond or two makes all the difference. And so how do you synchronize all this activity across multiple computers and collect all the data in a way that's meaningful, that allows you to do the analysis? And then from there, if you're also measuring behavioral data, how do you integrate that with the same kind of synchrony so that you get this bundled package of data that comes from multiple systems across multiple computers involving multiple people, package it all together in a way that allows you to analyze it? And there's a whole bunch of issues around that that makes that really interesting but really challenging. But then the really fun part comes to when you actually get the data package. As I say, no one's done this before, which means that no one knows how to analyze this kind of data. And so not only are we figuring out how we collect all the data and how we package it up, we're now creating new methods for doing the analysis. And do you analyze across multiple people at the same time? Do you analyze each person individually and then group them together? That's kind of the traditional approach. But when the measures that you get when people stop paying attention are really individual. So what might happen in one person's brain doesn't look the same as somebody else's brain. And so looking across a group of people, you actually see almost nothing in the data. But when you start to look individually, then you can see really marked differences. And so what it means is that we have to look at this as a within student kind of phenomenon. And so then you start looking at, okay, how do we scale this? Once you get around the issue of how do you sort of collect this data in a classroom, which is solvable, but how do you scale it so that you can sort of get this data in almost real time from about 100 people and then feed it back to an instructor in a way that's useful so that they know, okay, let people stand up. And so we've turned to a machine learning approach to kind of classify these types of data, and we're getting there, but that's sort of one of the interesting questions and some of the issues around that type of data set. Okay, hat number 2. I am now the director of the education for the Department of Surgery, one of the hats I wear. So just as Lawrence was talking about medical school admissions, one of the things that we're looking at are how can we make medical training, and in particular surgical training for me, safer. The way that surgeons are trained, they go through basically 4 stages of training as part of the training. And so they'll go through the first stage, and then a committee will sit around and look at how have they done on the wards. And you're probably going to learn more about the medical system than you want to learn in the next couple of minutes. I apologize in advance. So how do you make these doctors safer, and how do you know when they're ready to move to the next stage of training where they get more responsibility and they get to do slightly different things? And so the way that this happens is that a committee will sit around and look at what's their performance been like on the ward. What are the mistakes that they've made? How much have they been able to do independently? How much are they trusted by their colleagues? How well do they form part of a team? You get all this kind of experience together, and then a committee will talk about each of the trainees, and then they'll make a decision about should this person are they ready to be promoted to the next stage of training, or are they not ready to be promoted? So you can immediately start to think about some of the issues around this kind of data, particularly in the context of open science and open data. So everybody knows, as part of a medical school, that you're working with trainees, people who are learning. So people who are learning make mistakes. The kinds of mistakes need to be recorded because that's how you know that people are progressing and you know that people are sort of going through the system. And the mistakes that people tend to be allowed to make are under supervision, and so they'll be allowed to get so far, and then somebody will say, okay, now you're about to do something that will probably cause a problem, so we're going to stop letting you do what you're doing now, and so the supervising physician will step in. So it's a safe environment, and so people are taken to a point kind of where they're just about to reach their level of comfort or their level of ability, and then they get pulled away, and then somebody else will step in to take over. So it's a perfect normal part of the education process. The same happens for engineering. The same happens everywhere else. But if you think about what would happen if that data was made public, and what might happen if 15 years down the road there's a medical complication and the medical education record comes out and says, okay, well, back when you were 21 years old, you had a problem in this one case when it was the first time you'd ever done something. And so now there's a similar problem 30 years later, so it must be related. Right? And so what happens with this kind of data? And so now around this environment for open science, where is it appropriate to make this kind of data available and where isn't it? And this is one of the challenges that we find really interesting to sort of struggle with. And there are quite traditional ways of redacting data. So you can kind of hide names and you can hide program names. So you could think that you can make it anonymous, but some of the training programs are very, very small. And so if you only have one trainee in a program, which is the case for some things, and you have a note somewhere that said a trainee in the brain surgery program did this and there's only one trainee, you can figure out really easily who it was. So even if you were to redact the data in kind of science, how does that fit with publication of data? And how do we balance these kind of the rights of the individual participants with the rights of society ways? If you were to make it available, you really are compromising somebody's privacy. And so with the push for sharing data. The third project I'm going to talk about, I'm putting on my I'm in the School of Biomedical Engineering hat. Also true, I do wear many hats. So one of the issues that we're trying to work with is how can we use technology to help physicians make better decisions. So there's a medical condition called hydronephrosis, which is, I mean, it doesn't matter, but it's basically a kidney disorder. And you can detect this kidney disorder by taking ultrasound images of the kidney. And when you take the ultrasound images of the kidney, the images get graded to 4 different stages, and then depending on which stage it is, the treatment plan changes. Problem is, no one really knows how to classify these things. So there are 4 different scales for grading these types of images, and physicians generally agree on sort of what's a 0.1 and what's a 0.4. The difference between a 1 and a 2 is relatively clear. The difference between a 3 and a 4 is relatively clear. The difference between a 2 and a 3, which has a major difference in treatment implication, is much less clear. So what we're doing is trying to use machine learning-based classification to create a tool that will help doctors to make better decisions, and kind of really just create a diagnostic aid tool. So not replacing the doctors, but giving them something that they can use to help them be more certain about their decisions. This project came to us when a physician came to us and said, I have this fantastic database of images. We have 10,000 images of 800 patients, and we're going to be able to do this kind of research that nobody's been able to do because this kind of database of data doesn't exist. So far, so good. It's not a huge number of images for machine learning, but it should be enough. But what we found was that the quality of the data is terrible. And so we have all these ultrasound images, and they're supposedly ultrasound images of kidneys, but when you look at them, some of them are actually ultrasound images of bladders rather than kidneys. So you have different body parts being imaged. And these are ones that have been diagnosed by physicians. Like I said, you're going to learn more about the medical system than you should. But physicians have actually graded these things and have made a diagnostic decision around them. But they're wrong. And so you start throwing this stuff into a machine learning algorithm, and it's learning off bad data, which means that it can't make good decisions. And so sort of the big issues around this sort of data set is, particularly for clinical data, how can we start to put in place policies and procedures that assure good quality data and quality assurance at the point of collection? And how can we do this in a way that doesn't take so much time that the clinicians have to spend less time treating patients? And so as we move into this world of big data, and particularly open data, how do we make sure that the data that we're putting out there is what we think it is? And how can we make it useful for other people? And I think that's probably my 5 minutes, so I'm going to have to shut up. Thanks, Ronald. All right, there we go.
Thanks, Jay. So I wear lots of hats too, and I'm going to talk about 3 things as well. I wear lots of hats In fact, I wear more hats than I can actually wear very well. The advantage, of course, is I get to go to lots of holiday parties, so this is the, hence the sweater today. The reason I want to go through the three hats that I wear is because each of them is going to be related to a question that I'm going to mention. So I'm the editor of Canadian Public Policy Analyse de Politique, and if you're a researcher in the social sciences, please send us your stuff. We are one of the fastest moving journals in the public policy sphere, and we're also been around 45 years. I'm also the director of the Productivity Partnership, which is a national partnership, but it is centered here at McMaster. And if you have research that sounds like productivity, we'd be interested in talking to you. And then I'm also the academic director of the McMaster Statistics Canada Research Data Center. And because McMaster is the host for the national network, as part of that, I've become principal investigator of the grants associated with the Canadian Research Data Center network. And I do things like I serve on the Joint Operations Committee of that network, and that means, for example, issues of replicability and reproducibility come to me as in that role. And so we work on those things as well. So the next slide, please, Jay. So I'm going to give you examples centered around these three things. The first for the journal, and I want to say right from the beginning, I'm a sinner in this space. And most of the sins are associated with the journal. And the reason is the journal is not all that well resourced. We have lots of trade-offs that we have to make. So I'm going to give you an example of one right to start off with. We are going to publish an article based on the Kitchener-Waterloo implementation of a light rail system and what it did to real estate prices along the announced sites. Now, this work probably would have been possible totally with publicly available data, but in fact, the researchers used a proprietary data set of real estate prices. So by the time it has come to us, we have to make a decision because it's proprietary data, it will not be reproducible in the ordinary sense. You can't just put the research out, the data out there and have somebody else do the research. On the other hand, it is research of compelling public interest. So we had to make a decision as to whether we would accept that research for publication, and we made the decision to do so. But it's clearly, at some level, not where we want research to be. Research in this type of sphere should be reproducible, and it is not. Another example we had is we had authors who, now turning not to proprietary data, but confidential data, they were using confidential data. So there's two problems with confidential data. One of the problems with confidential data is by the nature of it not being public, it's away somewhere, and you don't know, it can change, and you don't know that it's changed. And so what happened is that the researchers, in between their initial submission and their revise and resubmit stage, the data changed, and they could no longer reproduce their own results. Right? And it wasn't their fault, but that's what happens, right? That was a different kind of case with a less satisfactory outcome for the authors. But the problem still is that in confidential data, that going away from the public eye has another problem besides the more obvious one, which is being confidential data. How do you ensure reproducibility? Normally, that has not been as much of a problem for our journal because usually what can happen is researchers can go in and wish to reproduce, can go in and get the same access to the confidential data subsequently. It usually costs some money, but we've made provision for that within the journal. And that has not been as big an issue, but it's still not a non-issue. The third one that I want to mention in this context is to do with public data, the third one on my point here. This is a very old problem in the social sciences, particularly with economics, my discipline, is that, for example, the national accounts, when you hear about things like GDP, you think of that as being a number. But in fact, it's a series of numbers. It's revised all the time, and revisions go back many years sometimes. And so it's entirely possible to have a result that was right for the data that was available to the authors at the time, which is now wrong, right? And so what you want to ensure, once you want to do the forensics to see what happens if the result changes, the first thing you'd like to know is, well, did the authors get it right in the first place? And that means, of course, that the data had to be curated, that the original version of that data had to be curated. And that has not always been done. And so sometimes that's a tricky issue. Turning to my second area, working with the productivity partnership, all you really need to know for this little bit is that the productivity partnership uses a lot of data from individual firms. And of course, because it's individual firm data, it's been collected on a confidential basis. It has to be kept confidential at the individual level. That does create some barriers for reproducibility. As I said, we don't have the same issues there if researchers can go back in and access those data and do the reproduction. Nonetheless, it is a peculiarly expensive process. Individual data, it turns out, maybe we'll get into this in some of the later questions, the individual data, even the confidential individual data, it's usually not that expensive to do reproducing projects or to do new projects, but the firm data requires a much higher level of disclosure analysis, which means that somebody from Statistics Canada has to look at the results much more closely, and you have to pay the person from Statistics Canada while they're doing that, and it becomes more expensive. So there's issues we face there. The final one I'm going to talk to in this round is this work with the Canadian Research Data Center Network. So McMaster has a research data center right on campus. People who are interested in using it, you can talk to me, and there's other people around the room here today who are experts at this, and learn about that from them. There, again, there is the issue with confidential data. But here, at least we're on a process or a path to perhaps reduce the rate of sinning rather a lot. And Randall's involved in this, and Seppo Sarkarpi in this room is involved with this, and other people as well. And basically the idea is that as part of this network, we're trying to get so that there's a standard of reproducibility across the whole network. And basically that just means saving lots of things. Now it's hard because, again, saving a set of data in the social sciences is not always that easy. Sometimes there's linkage issues involved with data sets that are linked to other data sets, and maybe we'll get into some of that later. But at least in this particular project, we at least have the glimmers of a solution.
Great, thanks, Mike. Okay, so this is where we're going to turn it around and give everyone a chance to take a breath and ask you if you have any questions or comments on those responses. This is where everyone avoids making eye contact.
I'll start with Ranil. How did the people react when you mentioned to them that their data was so bad of the kidney? You know, how did that go over?
They were a little surprised, and then we had them review it. And so when we got the data, we asked, okay, has this been validated? Thinking, and we were told, yeah, 3 people have looked at all this data. But it turns out that when 3 people look at the data, it's 1 lead physician and then 2 of their trainees. And so, of course, they're all going to agree, because the boss is telling you that A is A. So, of course, it's A. So they were surprised, but they went back through, and then they was like, oh, we need to go through this more carefully. And so one of the things that we've actually done now is we've been able to take the machine learning tool, flag all the images that it misclassifies, and send those back to the team and say, okay, can you look at these images, because the machine learning algorithm really got it wrong. And 8 times out of 10, those are the images that were badly classified. So we've been able to take the diagnostic tool that we tried to do and use it as a mechanism for cleaning up the data so that we can then retrain the tool. But it was a surprise. They were convinced they had the gold standard best database. And that's quite common, because people spend a lot of time kind of curating this data, but sometimes just don't do that last step of making sure that it is really what we think it is.
Nicole, do you have a question?
Yeah, thanks. My question is also for the broader panel, but it's to a point that Ranil made also about anonymizing data. And so Antonio mentioned also that we're living in such a data-rich environment right now, and so even if data is anonymized, having multiple data sets, you can kind of re-identify data. And so I was just wondering if anyone has ideas or suggestions of how you are mediating this now, or is there any way to mediate it?
So I guess I'll start and then maybe turn over to Antonio. I think being aware at the beginning. So no, there was this really scary data that came out about 1.5 years ago that showed that if you just take 3 pieces of data about somebody, you can pretty much now identify them down to their postal code. So down to like the 6 houses that they live in, with almost any 3 pieces of data about them. And so I think the onus is really on the researchers to be aware of that, and to be aware that as we get more and more sophisticated machine learning algorithms, and as more and more companies are interested in finding out exactly who you are, linking data sets is going to make it really easy to find out who people are. And so the onus is really on us as researchers to make sure that if we put any data into the public domain, we've done everything we can possibly to think about all the scenarios that this data could be used and could be linked with, and to put restrictions around that data. So I don't think it's the case that we shouldn't be publishing the data, but I do think that we should be putting restrictions and warnings around the data so it can only be used in particular ways for particular things. I think open science means that data has to be reproducible. It doesn't mean that everybody has to have access to everything you've ever done. And I think making that distinction as we develop the policies is going to be critical.
And also from a geographical perspective, so I'm in the School of Geography and Earth Sciences, the challenge is that, what was mentioned, you can identify to the postal code, right? If you couldn't do that, it wouldn't matter, because you could be one of maybe 10 people, but you don't know where that person is, right? So the challenge is even bigger when you have geographical information as part of that, and it's it has 2 aspects. One is that it becomes even more sensitive, because you can identify not only who someone is but also where they are. Whereas on the other hand, the challenge is that if you change that, you also change the properties of the data set. There's research, what I've seen has mostly been in epidemiology, where they're interested in exposure to pollutants and things like that, and so they want to make those data sets accessible to other researchers, but at the same time they cannot tell you this is the address, right? The thing is, if you jiggle or you distort that using random numbers or what have you, you have fundamentally changed the properties of the data set, which makes it extremely challenging. Something that some of you may have seen recently, it was reported just in the past few days, I think, is that the census in the United States is planning to release in the future, or is thinking about releasing in the future, census statistics that are wrong in a deliberate way, precisely because of that issue, that now there are so many other data sets, some in the hands of industry, university researchers, and so on and so forth, that you can sort of match things and obtain, basically reverse the process and identify individuals based on what the census tells you, and stuff that you get from a telecom, from a bank, from this, and that. So the census is at least considering, maybe planning to release census data that would have been altered in ways to minimize that risk. So I'm really ambivalent about that, because we know that those changes may actually change what we understand about processes, whereas at the same time, the imperative of making sure that people are safe when they're sharing their information.
I wonder if I could just say something here. At the Canadian Research Data Center Network, or the McMaster version of the Research Data Center, so we have all the Statistics Canada data sets where people have responded to surveys. We also have a lot of administrative data. So for example, the data that I've worked a lot with is anonymized tax data. And it is obviously very sensitive, but there is somebody there, what's called a disclosure analyst, they'll talk more about this afternoon, whose job it is to make sure that I could never identify an individual or even come close to identifying an individual. And the essential way that is done is, as Randall says, is that you don't have to be able to get the actual data to reproduce or to analyze. All you have to do is be able to recreate the same set of aggregates. And so the groups of people we look at are 50 or 100 people at a time, would be kind of the smallest cells we look at. And so people get mixed in. And there's lots of work to prevent. For example, in principle, it might be possible with successive replications of the research to get closer and closer to identifying an individual. And they prevent that. The rules prevent that.
Okay. Well, I think we're going to move on to the second question here. This may be the only question of the remaining two that we get to. But it's interesting to think about what we've just heard from the panelists here about the broad challenges that are technical in nature, but also cultural and social in nature, and to think about how the pending tri-agency research data management policy might affect their work, and any remaining questions they have about how that's implemented or what exactly that looks like. So I think we'll go through the same order again. So Lawrence, we'll go back down to you.
Okay, thanks, Jay. No need for the slide.
Okay.
I'm not really sure how to answer this question about how the new policy might affect my work. I'll admit to being a late add to the panel and having only a vague understanding of the policy to begin. I did give it a deep read over the last couple days in preparation, and I'd say I came out of it feeling that it's still fairly vague, and I'm getting the sense that that's why the group is all together and talking about it. So rather than posing a bunch of questions sort of generally about how this might affect our work, I figured I'd just talk about some of the alignment between what I see in this document and some of the experiences we've had as we've moved through the management of data locally in the medical schools, and then provincially as we bring our groups together. And in that regard, I think that there's a really salient resonance with this focus on establishing strong local data management plans and the value of that, and how important that's been for us in brokering relationships where people feel confident that we can move forward, and that's happened at a number of levels. In order to conduct our analyses around the relationships or the predictive value of admissions factors for medical student performance on licensing exams, we first needed to gain the confidence of our own medical school about how we were going to use our own data with other people. And in moving that forward, we really recognized that there isn't an established data management plan at the university in the medical school, and very little consideration had been given to how is data stored and how is it used and how is it accessed by researchers. So in step with what I'm seeing in the policy, we've worked with our own medical school to establish data sharing plans that protect, again, student interest as well as institutional interest. And then that's just the first layer. Moving into the next layer, we're recognizing that if we're going to connect this data with similar sets from University of Toronto and Queen's and Northern Ontario School of Medicine and the 6 medical training institutions in the province, that we're going to need to have a data management plan at that level also, and then that would have to take on a slightly different look and feel than what was relevant for us locally. The big difference between this provincial management plan and the local management plan was a strong dissociation of the governance for the resultant data set from the research interests. So a lot of the times here locally, I'm asked as the PI for this work to sort of wear both hats in terms of establishing the plan and access, and then conducting the research and asking the research question. At the provincial level, we recognize that there's a major conflict of interest for the researcher and the research group to be making decisions about what's A-OK for data that belongs to different stakeholder groups. So that management plan, facilitated by the OPHRDC here on campus, has involved the building of a governance structure which has representatives from each of the institutions involved, so the 6 medical schools, the Medical Council of Canada, OMSA, which is the Ontario Medical Student Association, so that they can come together, look at our proposal, which is a pilot or a case study for how this work might happen later. And again, we do see that the resultant data set has tremendous utility above and beyond the particular research questions we're asking, and we're already getting people asking us, well, how can I get my hands on that? So to be able to direct them to a governance committee where they can then submit an application for for access has been really valuable. So in that regard, I'd say with alignment to the Tri-Council policy, that we are experiencing the need or the imperative for robust data management plans. So I think that in this sense, the push from the Tri-Council is very important. And that this is this not only having advances for us locally, but also in the way that we communicate and collaborate with other institutions that have large data sets of importance for education research. I'm hopeful as I hear the others speak, though, that some more questions might come to me, and it'll be stuff that I can take back. So, as a panelist, also an audience for this event. So thank you, Jay.
Yeah, I think we're all audience members here too, Lawrence. So don't feel you're alone. Thank you, Antonio.
Yes. I will ask maybe Vivian. When was the Dewey Decimal System invented? Longer than or as long as libraries have existed? Right? Right. So it's probably been around for decades, maybe, whereas libraries have existed for thousands of years. So it's not a surprise that these policy guidelines will be vague in that way, because we're basically making it up as we go, right? With something so new that we don't have yet a decimal system to tell us how to store data, how to index, how to retrieve, how to find, and so on and so forth. In that sense, I think that when I read the policy guidelines, it was like I don't really know how this will affect my own research because it's kind of vague. I came away with the impression that the intent of the policy is in the right place, is in the sense of pushing data whenever possible to more potential users and making sure that there are all these things with reproducibility and so on and so forth that those are in place. So it's still vague how that will happen, but it's clear that that's an objective. Not clear how that will impact, my own research, because I have been doing research without a data management plan for a long time. But thinking about how things might change under the intent of the policy, I will say that it will probably make my life easier and more fulfilling. So one thing that I just started to do recently is I created a GitHub repository. So this is kind of geeky, but it's something that we don't have an institutional equivalent for that, a place where I can just put on my research scripts, documents, and so on and so forth. But at least I have that. There are some resources for that, even if it's not institutional. I have a GitHub account and a site. And what I've been doing recently with my last 2 or 3 papers, I think, is all the data that was open, it's right there with every single document that I used to process from the raw to the final tables that I used to do the analysis, along with the modeling, along with my rationale for doing every single thing. So I think that the intent of the policy is to make sure that we are not doing that 20 years into our careers, but we're doing that as grad students, as research assistants, so that every single thing is it's the way one of the big names in this movement towards making data more transparent and usable is document everything in such a way that someone else can understand and replicate what you did. And that person might be a future you, right? I guess most of you have found that, 3 years later, coming back to a data set, I don't even know what I did, right? So it might be even yourself at a future point in time, but making sure that it's in such a way, it's documented and scripted and so on in such a way that anyone could come and understand precisely what happened. And I think that potentially the way the intent of the policy will change my research is that it will push me further in that direction, but not only me. It's something that will move the academic community in that direction, which I think will be a net positive.
Thanks, Antonio. Krisha.
Thank you. I'm going to largely, I think, echo what we've heard here today. An interesting point that Antonio made was that these activities started as a grad student, and in our, in this moment where we can influence the grad students, we can kind of plant those seeds of proper data management. And the effect of the try, cancel policy, I think, one, I hope that it will serve to kind of normalize research data management. So it's going to bring it to the forefront and kind of get it into our psyches. So it will become part of the progression of our HQP. It'll also strengthen the value of research data management for our researchers in that, tri-council funding is very, respected and sought after. And if it's something that they need to do to achieve that, then it will incentivize them in a way. It will also, I'm hoping, focus some of our resources. I think in the process of looking at our research data management for our group, the disparity in resources and across institutions, across even departments and faculties, even across researchers, depending. Those resources are hard to find. Lawrence mentioned moving from being a researcher to a relationship builder. And so now we're asking researchers to move from, carve another chunk of time out to make their data that is, perhaps fully usable for themselves to be, documented in such a way to provide that resource for others. And I was at a metadata discussion group a few weeks ago, and the question was posed, what's the value of metadata? And someone said, to get you off my back. And it's kind of like, so there's like kind of a, people kind of brush up at the, I think at the weight of this and the work that it implies. And so I think that, so we, in our group, we have implemented a number of things like research data management plans. Kind of the gap was kind of the in-between part. And so we've got the planning part, we've got the, curation at the end, we've got, that sort of figured out, but just helping people to kind of turn it from the plan into something that they can do without it being such a huge task. And I think that that this policy will hopefully bring a lot of those resources together. One of our researchers received a Canary grant to look at a portal for active research data management. And I was looking through all of the different things that got funded, and there's so many commonalities. People want a discovery tool, they want, storage, and they want, so it's kind of like so many, like across the board, there are commonalities in what people need. And if this policy can focus resources to provide a structure and to support researchers. Antonio mentioned being, geeking out with GitHub and stuff. GitHub's fantastic. A lot of people aren't as open or, they're a little bit intimidated by it. And I think hopefully this policy and bringing it to the institutions to call upon them to support, not just the people who are like great at R and great at, GitHub and all these things, but to support and kind of provide a roadmap for people. So provide the tools. One of our researchers, went through the ethics board and was given this long list of things, and they're like, how do I do this? And I'm like, I don't know, let's try and figure it out. And it's not a direct, it's not, people need to know what they need to do. The disclosure analysts and people who are knowledgeable. We can't expect every researcher to be, fully knowledgeable about all of the different pitfalls with respect to data. So if we can build in an infrastructure or a support structure where we have knowledgeable people on, on the technological side. So provide them with the resources that are as easy as Dropbox. But more secure and more in control, and provide them with someone who can advise them on how to handle, sensitive data. I think it will provide them the confidence to share their data. And so, yes, I think that's my perspective on what I hope comes of it. I don't think it's going to be a immediate thing, I think, but it's planting the seeds, and hopefully that kind of ecosystem grows.
Thanks, Krisha. Rano?
I'll just share a few of the things that come to mind when reading the policies and thinking about this. The first of which is that students at this university are the research engine. Most of the work is actually done by graduate students. And I think one of the things that the policy really made clear to me is that there's a real lack of clarity around who owns data. Does the data belong to the graduate students? Does it belong to the supervisors? How does that change as a function of how the research is funded? And then, who's actually responsible for sharing this data and making it open? If the data is owned by the student, should it be them? What happens if they leave the institution after 2 years, after 1 year, after 3 years? How do we make sure that data remains available? There's an entire kind of stream of consciousness around that. But on a related note to that as well, given that students are partners in research, how do we train them? Right now, most training around research data management for students happens within labs. And so for students who work with 2 or 3 PIs, they may have very different perspectives with each of the PIs. And so it can be really confusing for them to know what are good practices and what are best practices, particularly if they then span different fields. So I think as an institution, one of the things that we need to be thinking about is how are we training the next generation of scholars, and how do we integrate data management right into the curricula? Not as part of research methods, not as part of statistics that a whole bunch of students think doesn't apply to them, but just in terms of if you're going to be collecting data, what are good practices and what are best practices? On a somewhat related note, we talked about, as a researcher, I spent years of my life collecting this data set. I want to keep it so that I can milk it and get everything out, because my academic success depends on me getting publications. So until we find a way of having institutions value sharing data as part of the tenure and promotion package, as part of academic activity, I really don't think that the policy is going to have any legs and will gain any traction. We need to find ways to incentivize people to do what is best practice. And so there's a lot of work that goes into making a data set available. By the way, Antonio, there are actually institutional tools for doing exactly what you want to do. So the fact that you don't know about them speaks volumes about how poorly you communicate that. But given that it takes so much time and that there are so many demands on people's time already, unless people get value for doing this, they will never do it, I think. And so we really need to find ways of incentivizing that. And I think we're running out of time, so I'll stop there.
Could you put my third slide up?
Of course.
So I'm going to stick with the reproducibility lens. It's not the only lens to look at these things, but just for brevity, I don't want to speak more than another minute or two. But again, you recall the 3 roles that I have that have different aspects for this issue. And the first is so the part in bold here is that I'm talking about now. The journal. So what journals are doing in the social sciences increasingly is they're having somebody called a data editor. And that the person's job is to not worry so much about the content of the article, but to make sure that the results would be reproducible. That means that the journal will have a deposit arrangement for the data. That may turn out to be problematic in the future, but this is, I think, a trend to actually have the data on deposit, certainly a method of accessing the data on record. But otherwise, it's probably going to come down to authors. I take Ranel's point about the issue as to incentives, but I don't have more to say on that. So I'll go on to my second one, which is the productivity partnership. So there we're doing a lot of work with Statistics Canada. Statistics Canada is the holder of these firm level data that we use. And so there's some sense in which the results are going to be reproducible, because Statistics Canada is kind of an automatic depository. But it's more complicated than that because of linkage issues. And again, it's going to come down to some mixture of authors and Statistics Canada. The third one I want to talk about is the McMaster Research Data Center, which is a member of this network. Now, it's a very nice place to work. If you want to go over physically, it's a nice room, but you're inside a room. And if you are working on a computer, you're working on our computer. In principle, we, at least in the future, could keep track of every keystroke you make, every data point you generate, the work could be completely reproducible in the sense that a complete record of the data and all the things you've done to the data could be kept. The trouble is that isn't really quite what we mean when we mean reproducibility, because what it's going to be there's just too much, right? If you sent it to some other researcher and said, you did this, and what really would have happened is you'd have gone down 12 false alleys and ended up finally with your final result. So it's not really reproducible. But if we thought of that as being a reproducible standard, that's at least technically possible. But it's incredibly costly. It's either going to be costly to the person who eventually tries to reproduce, or it's going to be costly to some analyst in between who tries to fix up this big mess you've made and made it into something that is sort of comprehensible. So that would be really costly. It is possible, however, that kind of 90% of it could be done more or less automatically. And then the 10% would have to be the authors accessing tools that are provided within the facility, which just says, this is the way you archive what you've done. You just do this, this, and this. So that's where we are, right? But the problem is that 10% supplied by authors still has to be done by authors because it's a very expensive thing to have done by other people.
Great, thanks, Mike. Okay, so I think we have about 10 minutes or so. I'm more than happy to open it up again for questions or comments, or if anyone wants to share your experience as well, and ask the panelists their thoughts on that too. Yes?
I'm just going to add to Neil's point about grad students. I think the other thing that people don't always think about is not all grad students are part of labs. So if they're not part of a lab where other students are teaching them, which is also kind of problematic having other students teach other students, that's something that, depending on the supervisor, they may just be figuring out on their own. And so that was my personal experience, and I think it speaks for a lot of people.
Yeah, no, you're absolutely right. And I think we need to do more to establish support networks that encourage good habits. And that can be from peers. I actually don't think there's anything wrong with senior students who have experience with this, teaching less experienced, providing it's done under supervision and within a framework. I think that you want to avoid sort of people who don't really know what they're doing, teaching the next generation of people to do it. But I'd like to think as part of a graduate school experience, we're getting better at supporting graduate students through that. I know we haven't historically done the best job of that, particularly in some areas, but yeah.
I had a question in the back.
And if I may add to that, I think that I would think of the process of mentoring among graduate students, so senior graduate students helping younger graduate students and so on. So that's actually part of the process of learning. The issue is whether that is done with the system. So that's one aspect of it. So that, it happens in a systematic way. Now, that's not enough because you could have a system to do things poorly, and it does things poorly consistently, right? So you need to have a system that's also gone through some quality assurance, that, the system does something, but, that it actually gets you something that is high quality. And that's, as it has been mentioned, some of this is actually asking people who are already very busy to do more things than what they already do, right? So one of the challenges is, and again, it's kind of vague there in the policy, who pays for that? I mean, and I think we see that also in the case of knowledge brokers and knowledge translators, that the agencies really want to see that there is a knowledge mobilization component, but they won't pay for someone to dedicate themselves to do that, right? I think that we may find that we are in a similar bind in which we have, the demands for having good data management protocols and so on and so forth, but, that if there is no dedicated funding for that, that's just going to pile on the responsibilities of people who are already way too busy.
One of the things that I'd really like to see is most grants come with a section in the budget for dissemination. And historically, dissemination means you can put $2,500 in a grant so you can go to a conference. If the agencies would rethink that so that we could put that money towards making data more accessible, then that would be a good way of actually funding some of this work.
And those of you who recently know that there is, a few standard classes, so salaries for grad students, travel, this and that, and then you have 3 lines, other. And so if you want to put, dissemination, even if it's open journals, and there is a policy for open publishing, if you want to do that, there is no line there for it. You have to put it in the other class. So I think that makes a lot of sense. I mean, that these policies will be hard-coded into how you apply for money. So you say open publishing, yeah, you want that? We are asking for money for it. We don't put it in the other class. You want to have data management plans? Yeah, we have that as an item, a line item that we ask money for.
Absolutely.
I think that that's a really good point. I think that often the research data management comes after the grants have been written. So when people want money for some of the support services that they need, it's not there. So all of their money's been allocated elsewhere. So they're, being asked for money that they don't have necessarily to support that. I think too that with respect to the, I don't think research data management can be left to individual groups or individual researchers, because there will be, there's a disparity in uptake, maybe interest, knowledge, all of those things. So I think it has to be at a, an institutional, perhaps even broader sense. Maybe it has to be even, national or something like that, whereby resources and experts and guidance can be offered from a place of authority, where we have. I know I read one thing about a system at Purdue that was put in, and they have a system that is available to everybody. So regardless of whether you have millions of dollars or you have no grant at all, you still have the platform to make research data management happen, and it would be then accessible to everybody, whether you were an individual grad student or someone in a lab. And that also provides the support. So you've got the guidance to help you get, go through and move through that system. So I think that that's kind of maybe one direction that needs to be going in and pursued. And then just with respect to knowledge mobilization, it's kind of interesting because our project is really heavy in knowledge mobilization. We've got 4 knowledge mobilization specialists working, and it's still a challenge to build the knowledge, build the understanding and value, in our program. So anyway, I'll just stop there. Thanks.
I think we have time for one more question if there's one over here.
So I was just curious, because there seems to be appetite for either data management third party or something along those lines that meets everyone's needs. Is there no organization that's stepping forward to do that? I'm asking because I'm the local lead for the ICS, if that's right. And we have a pilot project that's supposed to be doing all this. So I was just curious if there's no existing third party that's going to, we're working on a platform that can basically do all this sort of thing for people who have their own data, not our data. So I was just curious, is there no third party already that's sort of trying to build this niche? Or is everyone sort of going on their own tangent sort of thing?
So yeah, I can handle this one, and I'll tackle it on various levels as well. So there's a relatively newly formed group here at McMaster that's a tier 3 IT committee that's focused on research data management. And so the charge of this group is to bring together these various stakeholders representing some of the groups you see here and some other groups, including your group as well. Talk about these challenges and then think about how we actually address the needs that we assess across campus and how we can do it in an economical way and in a way that's fair as well to all groups involved. I think we have a lot of work to do with that as we're fairly new. At a broader scale, there is work that's going on, and this is a perfect segue into Jeff Moon's talk happening after the upcoming break. So there are groups within libraries and there are groups within high-performance computing all the way up to Research Data Canada. and I said as well, so at the national level, that are working on this and are interested in this. I think it's safe to say there's a long way to go to actually build that infrastructure that we need. So I don't think there's any expectation that this is a quick fix, but it's something that there seems to be interest from the top all the way down into tackling this and ultimately improving the the research experience for all researchers and all groups.
I'll just add to that. So there are actually probably at least 7 or 8 third-party entities that are interested in doing this, both at the provincial and at the national level. Carl is one. Compute Canada are interested in this space. Canary are doing some work in this space. One of the genomics computing groups is doing work in this space. There are many different people. The problem is none of them are talking to each other.
And Jeff will talk a little bit about that, about the work that he's done to try to get people talking.
Yeah.
So, okay, so that brings us to our break. So we're going to reconvene at 11 o'clock for Jeff's keynote talk. But I want to take a moment and express sincere thanks to our panelists for joining us today. Thank you. I think he's turning on. Okay, everyone, if you could find a seat, we'll get going with the keynote lecture here.
I know I'm between them and lunch. But if there are questions, I don't mind taking them until like it's entirely your call. And I will try and be done as close to noon as I can. If I'm done a bit early, that's better. But if for any reason
Yep. Okay.
I'm pretty good at judging this, but it depends on how quickly I move things on.
Okay. I mean, it would be a good problem if there was tons of questions, right? Yeah, predict one time. Okay, so we're going to get going with the keynote here. So I'll give everyone one more minute to find a seat, and then I'll introduce our speaker.
Lots of seats at the front here.
Okay, so I'm very happy to introduce and kick off the second session of the morning here, which is a keynote talk by Jeff Moon. So to give you a little bit of information on Jeff, so Jeff is the director of Portage, which is a national library-based network launched by the Canadian Association of Research Libraries, otherwise known as CARL, with the goal of building capacity and coordinating research data management activities in Canada. So prior to his role with Portage, Jeff served as data librarian at Queen's University Library and as academic director of Queen's Research Data Center. He has also managed the Queen's RDM service, so he has lots of experience working with this in a hands-on manner. Jeff also teaches a graduate-level RDM course at Western University. And so we're very happy to have Jeff here, and I think we've been speaking for about a year or so trying to find a date that worked out for everybody, and I think we found the perfect one. So please join me in welcoming Jeff.
Thanks, Jay. That was great. And I'm glad it was a brief bio because you didn't have to mention how many decades I've been at this business. So, is this can we get this so it doesn't ring as much? Is that? I'll just keep talking until the ringing goes away. Maybe it's just in my head. I don't know. I wanted to know maybe if I stand a bit further away. No? How about that? Okay, it's ringing in my ears, but that's just me. Okay. I wanted to take a quick poll of the crowd. Just self-identify, and for some of you, you may find this to be a bit embarrassing, but it's only me looking at your hands. Nobody beside you or in front of you or behind you will check. How many of you here are graduate students? Not too many. Okay, how many people are early career professors? And that's the hard part, because some of you might think, oh, do I just have... Okay, mid to late career academics, okay? And admin / IT, okay? And librarians. All right, so who wins this battle? It was the admin / IT folks that seemed to be the most populous in the room, which is probably a first for me. A lot of times it's researchers and or librarians. Anyway, that's interesting. All right, let's keep moving on. How many of you, just by the way, before today had heard of Portage? All right, well, that's encouraging, given that we've been around for a couple of years now. All right, well, let's get started. I'm going to go quickly through some slides that I think you have probably already been shown a little bit today by Jay, and perhaps we'll move as quickly as we can through them. If there are questions that arise based on some of those slides, don't hesitate to ask. And by the way, if you do have questions of content or whatever throughout, don't stop. Just ask the question now. If it's a longer question that might be best taken at the end, we will do that. So there we go, now we're getting going. All right, so we've seen one rendering of a research data lifecycle earlier. This is just another more linear rendering of that. And within this context, we're thinking of research data management as a broad term within the research data lifecycle of looking at the structure, organization, maintenance, and overall stewardship of research data throughout the research lifecycle. And within that context, Portage is aimed to work collaboratively with partners to build capacity and better coordinate our RDM activities in Canada throughout the entire research life cycle. And again, we're trying to get you over the rough. I don't know, the portage analogy sometimes falls flat, but it's get you over the rough patches, make sure you don't die in the rapids. So this is what we're going to try and cover today. We're going to look at the federal RDM policy developments fairly briefly. We're going to look at further context for research data management, the why of this whole enterprise in Canada. We're going to look at the goals and outputs of Portage and developing a shared vision for RDM in Canada. So looking at the federal RDM policy developments first, we do have our tri-agencies involved in this with their emerging RDM policy. Looking at this, they do have a number of policy documents that have come out, but their main goal in this is research excellence in terms of project management, reproducibility has been mentioned already, avoiding duplication of work, and meeting journal guidelines. Research dissemination, that knowledge transfer piece that we were talking about earlier, in terms of data sharing, citation, and giving credit where credit is due, and interdisciplinarity, the notion of breaking down silos. They're also interested in expanding research impact within sciences, within disciplines, within society at large, and in the development of good public policy. And finally, with respect to research best practices, transparency, trust, a solid concern for the ethical issues that surround data, and the responsible use of public funds are all key. So there have been a number of documents put out. I think Jay alluded to 2013, there being a capitalizing on big data document that came out. I personally find the use of big data. Big data at one point, you couldn't get the Globe and Mail or open up your news feed without seeing big data in the news. And I liked big data, don't get me wrong, but there is what they call the long tail of data that a lot of researchers are doing which cannot be left behind. And so I just want to make sure that we're balancing off the needs of all data users of all sizes. A couple of other policy documents came out, including this more recent draft tri-agency research data management policy, which has been out there being socialized, if I can put it that way, for these many years. The first time I saw it was in May of 2016. So we're coming on year 3. So this is not a slow process. This is not a fast process. It's a slow process. But that's the way our government seems to work, with very cautious about this. They know that it's a difficult issue that, if done badly, will fall flat, as has been alluded to earlier. So we want to get this right. So online consultations took place. I know that the number of institutions and organizations, probably including McMaster put something in, have all been looked at and are still being looked at by the trade agencies now in terms of their finalizing the policy. So the policy, as Jay referred to, has 3 main pillars: institutional strategies for RDM, data management planning, and data deposit. Institutional strategies are intended to just basically outline a strategy, and this was purposefully chosen instead of a policy. Because as was pointed out early in the process, if you say they've got to develop a policy, universities are going to take years to do that, because policies are not trivial. Strategies, on the other hand, can be, we got together and scribbled some notes in the back of an envelope. Well, not quite that trivial, but a lot less formal process. You can put a strategy forward that speaks to a future policy, but it outlines how you're going to manage it from a university perspective. And this is a responsibility of the institution, not the researcher. The following 2 pillars, we'll just deal with the why require them, recognizes the important role of research institutions in RDM. It does give the institutions a chance to think about and address gaps in this territory on their campus, look for local solutions while leveraging national, regional and national solutions. And it does help inform the tri-agencies. I think this is one of the ones that is least recognized. As these strategies get posted publicly on your website, the tri-agency will be able to then get sort of a pulse of how things are working out across the country and see whether the aspirations of some areas and some regions of the country are toned down and some are a bit more broad and well-resourced, and they'll be able to see how they can address that, and may serve as foundation for potential requirements further on. The second and third pillars, the DMPs and the data deposit, are on the researchers to fulfill, obviously with support. But DMPs will be required for research projects supported wholly or in part by trade agency funds. Submission would be a condition of release for the funding. And for specific funding opportunities, DMPs would submit it at the time of application. I will have to say that these notes, which I saw used just last week by the trade agency, do not reflect the final policy. These notes reflect the consultation text that's been put out and socialized for the past coming on 3 years. My suspicion is that the language in the final policy, is just my personal suspicion, is that there'll be a much firmer requirement for DMPs going forward. And that's based on feedback from the community. So why require DMPs? They are an emerging international best practice. They do help researchers anticipate their needs throughout the process, and more importantly, help their institutions anticipate and address needs that might come up in the course of a large research project. They can feed into research ethics proposals and anticipate issues related to ownership, potential for data sharing, etc. They're just a good practice. Data deposit will see data, metadata, and code. So I was grateful when Antonio mentioned GitHub, because that is seemingly the natural landing spot for a lot of code-related deposits. But data, metadata, and associated code supporting journal publications, preprints, and other research outputs need to be deposited in a recognized repository sometime after the research is completed. A concern that was raised, I need to publish. I'm going to keep my data until I'm finished publishing. I'll just quell the concern there right away. There is no data repository out there that would not consider a reasonable embargo. So that if you need a couple of years to get your research done, and if you think it's 3 years, or you think you come back at the end of the 3 years and you just need another 6 months, that's all pretty much negotiable. They're not going to say, oh, you got to turn it public facing. If it's appropriate to turn public facing, they're not going to arbitrarily turn it public facing without your consent. It is something that we can negotiate with you. So why deposit? Well, data, metadata, and code need to be kept safe and available to the data creator, as was mentioned earlier. Maybe you are the future user, and appropriately to others. They need to make sure that our funds, our public funds, our taxpayer dollars are being used responsibly, facilitating reproducibility and validation, and appropriate data sharing. So we'll look at more on these policy requirements later and the portage response to them. But looking at further context for RDM, I just thought I'd sort of give you another sort of broader media-based view of data management. So what are some of the other factors? The other factors are growing public awareness of data, addressing pressures from commercial concerns, certainly government policy directions we already talked about, recognition of the value of data in advancing research, the need to verify results, growing demand for data, and journal policies. So let's just jump into these. And for those of you who have seen this slide deck before, my apologies, but I come back to my caribou. I'm a biologist by training going way back, and when I was in field work in Algonquin Park, we went out and caught moose, radio collared them, and then we were able to triangulate them as they did whatever moose do in Algonquin Park. These are not your mother's radio collars. These are high-tech geopositioning, GPS. They have a sensor that lets you know whether the caribou head is down. And down means what? It means I'm eating. Up means I'm contemplating the universe. Okay, so they know whether they're down or up, and they know what they're doing at that time. They've got a 10-second burst of video taken every 30 minutes or something like that, so they can get a sense of what the weather is, what they're doing, whether they're running, whether they're still, and so on and so forth. So the researcher, in talking to Nora Young on Spark on CBC Radio, said it's not trapping these, one-ton beasts and dealing with radio collars and all that. It's the data. It's the massive volumes of data that we're dealing with here. That's the challenge that we're facing. You may have heard of the lost NASA tapes. These were tapes that were, due to an archival blunder, they were lost back in the 60s and 70s. They were recovered, fortunately, because somebody still had a tape drive. And these actually were used to prove that there was microclimate change, sort of based on the footprints where the astronauts walked on the moon. And I'm not sure what the value of this in the grand scheme of thing is, but certainly it's just showing that if you touch an ecosystem, it can change the climate. And I don't know, I guess that was the main reason for that news leak. But the notion of losing data from the NASA program is a scary one. It's such an expensive enterprise. Why wouldn't that data have been kept safe? I've done you all a big favor in not showing you what I could have shown you with respect to wound studies, because I did something on compression bandaging of leg ulcers, and oh, please don't do that. Not before lunch. Anyway, I've got some nice clean bandages up there. We had a data set that a large nursing-based program deposited in the Scholars Portal Dataverse that Queen's University was using at the time and was still using. And that data set was a very rich resource. I really like the Global Water Futures project because they actually have a data manager. That's brilliant. Well, this project had a data manager as well. And in concert with that team and that group, that data was deposited, and this quote came back to them. Many thanks for sharing the raw data. If more research groups and industry would do this, we could save more lives and limbs. So the power of putting your data out there in some disciplines, if not all, can be life-changing for others. Data between disciplines. So if you think about what's the connecting factor between tree ring data, ice cores, cave formations, whale earwax, and bat poop, and sediments in ancient Roman aqueducts? What's the connection there? It's climate change. Who knew when you were collecting all this anthropological or biological data, and for who knows what purpose they were collecting bat poop, but whatever they were doing it for, it is now something that they can use to measure and deal with climate change. So this interdisciplinarity of data that you did not anticipate as you were collecting it is something which I think is going to be driven by a more open data society. We want to do something about research fraud. Again, you don't have to Google too far to find evidence of people stealing data, people misrepresenting data, people making up data, and so on. We also have pressures from commercial concerns. If you're a librarian, this is sort of an evil triumvirate, taking our researchers' products and then selling them back to us at exorbitant prices. And they want to sell us this. They want to sell us data management services. And the complaint of one librarian contact of ours within the Portage Network was that they're solving the easy problems and leaving the hard ones for us. But they'll charge you for this, quote, solution. And then you'll still be left holding the ball when it comes to some of the more challenging difficulties. The other thing is Google. I mean, I saw this and, there's, oh my God, Google's going to be in data. This is brilliant. I think this is great. I have no problem with this. If Google can drive traffic to your repository and to your data set, have at it. Let's get the data out there and used. And who's going to be where your students are going to go more than Google? I mean, they're going there already, right? In terms of growing demand, this is just a snapshot from August of the Scholars Portal Dataverse here in Ontario. And what I like about this is it shows the distribution of different disciplinary deposits over time, and the social sciences are clearly there in a much larger way. I think this speaks to the role of data librarians in the context of our universities in Ontario, who have long had a very close tie with the social sciences through their connections with Statistics Canada, the Data Liberation Initiative, and so on. So the social scientists have all been working with these librarians for these many years. But I think it's really interesting to see some of these other disciplines represented there as well. What I think I'd like to take away from this is that there are 23 parent dataverses and 1,000 or so data sets. But as of the time that I downloaded this, there were 76,000 downloads over about a 5-year period. So there's a lot of interest for data out there. And there are anecdotes I could tell you about more data downloads and people clamoring for data. But within this context, we've got government policy directions as well. And the trends in journal publishing move towards open science in Canada and internationally. And these international initiatives and best practices are all driving us toward a better management of our data. In February of 2018, a budget came down. We were not really, I wasn't particularly expecting to see anything in it per se. We were thinking maybe 2019, but it did come down with $572.5 million for digital infrastructure, research infrastructure strategy. What is digital research infrastructure, I said to myself, and where does RDM fit into it? Does RDM fit into it? Well, being a government documents librarian as well over the course of my career, I went and grabbed a document from 2015, which was under the Harper government. I was going to say regime, but that doesn't sound fair. I look back fondly on Harper now that we have somebody else down south. Anyway, leaving that aside. Data management is well and truly embedded within DRI, and so we are a part of it. And so life was good, and we knew that part of that money was going to be for data management. So looking at the goals and outputs of Portage. Portage has many partners in RDM, and I'm going to put a few of them up on the screen here. These are some of the key ones that we're working with, but this is not a fulsome and complete list of people that we've been partnering with and working with. But we certainly have been working with Compute Canada and Research Data Canada. Compute Canada is our high-performance computing enterprise across Canada. It's a regional, it's a federated kind of approach to high-performance computing. RDC is a branch of Canary, which is the network organization that brings you Eduroam, among other things. We've been working as well with Local Scholars Portal, which is probably no stranger to any of you, the University of Alberta, and our tri-agency partners, but also with many others. I'll focus today on what Carl's been doing, but the partners are going to show up. We have three main goals in the Portage Network. One is building a community of practice for RDM. Second is engaging stakeholder communities. And the third is developing RDM infrastructure to support researchers and institutions in doing RDM. So back at the beginning, we had something called Project ARC. And Project ARC was a badly chosen name out of the gate. Because ARC stands for what? Roy, are you in the room? Where's Roy? Roy, what does ARC stand for? Advanced Research Computing. That's not what we're talking about here. ARC also stands for, in the context of Carl, for the Advancing Research Committee. That's not what we're talking about, right? We're not talking about that. Well, what they were talking about when they coined this was the hotel they were staying at when the conversation took place, and it's as bad a reason to pick an acronym as ever was. So we are now Portage, or I can't even say it in English anymore because my wife is French, and so Portage. Anyway, so we are Portage. And back in 2015 when we started doing a lot of different things related to agreements, outreach, platforms, and governance, and we've been busy ever since. What I want to highlight from this slide is the blue lozenges there with the numbers in them, and those blue lozenges represent the numbers of in-kind volunteer support that we have in our institutions. And they include people from McMaster, they include people from every post-secondary institution within, well, most of the post-secondary institutions within Carl and beyond. They also include other stakeholder groups, as I mentioned earlier. We do have connections with a lot of groups. So we're building a community of practice. And the way we're doing that is to work with our network of experts, and these are that 100 plus network of experts, our RDM specialists and librarians and other stakeholders. And we have a number of expert groups and working groups on which they serve, and they are across the country. And we have 22 Carl libraries represented and 26 other institutions for a total of 48 organizations helping out with what we're doing with Portage. So moving on, the institutions themselves, we liaise within the institutions with other librarians, subject and discipline librarians, IT specialists, research offices, certainly with the ethics boards, and any other stakeholders on our campuses, including graduate student societies and so on. All of that work is done to support the researchers, either academic or potentially government or other. And underpinning all of this are these infrastructure platforms that we're going to get into. And these include things like the DMP Assistant, Federated Research Data Repository, and instances of Dataverse. So Portage has been very busy and productive in terms of some of its outputs. So one of the things that was mentioned earlier toward the end of the panel was we need resources, experts, and guidance provided with authority. And I said, I was looking at Jay, and Jay was looking at me, and I said, well, hopefully that's sort of maybe what we're trying to do with Portage here. So I think that resources, experts, and guidance should hopefully come through in some of what we're talking about here. And this is where you'll find some of those resources. Carl, in fact, and Portage was central in providing a major brief back to the tri-agencies on the policy. And that policy, this response to the policy was posted in July, a full 2.5 months before the final deadline. And that was put out there so that people like you and like others across the country could see where some of our thinking, based on feedback from a wide range of stakeholders, was going on this. And I think that this policy response helped inform and expand responses from other stakeholders. So we're very pleased about that. We also have these, I think, very nicely graphically designed busy bees, brief guides for busy people. And these are one-siders. You post them on your door and get people to ask you, what's this busy bee thing you've got on your door? It's about data curation, about Dataverse, about research data management, and there are a number of others being developed. Puis sont disponibles en français aussi. So, engaging and advocating for research data management with stakeholder communities is key as well, and I think I've alluded to a lot of that. We do work locally within our campuses. Certainly we support that kind of connection with the libraries primarily, but also with the researchers directly in RDM services, with IT, with research services, ethics, and our graduate students. We've reached out to regional and provincial stakeholders as well, primarily in the form of our 4 regional library consortia. And what that buys us is access to our Carl Library colleagues, those members, the 29 most research-intensive universities in Canada, but also the non-Carl libraries that make up our region. So these 4 regional library consortia do touch out to all of the universities in their areas. And in fact, down in the Maritimes, the colleges are included as well. And just as an aside, the colleges are just as concerned about this policy as the university sector. And we've been reaching out to them as well. And their concerns on the applied science side and the industry academic partnerships that take place and the IP concerns there, they're real and they're trying to deal with it. And if you think universities aren't resourced, the colleges, I think, could tell you a story. Reaching out nationally, we've been dealing with a range of stakeholders around this circle, as you can see, all related to the digital research ecosystem. And if you don't know what any of those are, I could tell you. The ISED one is Innovation, Science, and Economic Development Canada, which is the agency that gave us the over $500 million for DRI. We've been working across the board with all of these. So looking at the development of RDM infrastructure, we have these 3 pillars. It is the focus of the initial work of Portage has been to address these so that researchers and institutions aren't left completely at ground zero starting out on these issues. And the way we've done this is to look at institutional RDM strategies by creating an RDM strategy template document, which committees like the one that Jay is chairing can look at and say, do we agree with what's here and would we build our strategy around this framework or not? We have data management planning through the DMP Assistant, a national online bilingual data management planning tool, and national repository options, 2 of which are FRDR, Federated Research Data Repository, and Dataverse. And looking at each of these in a little bit more detail, I'm going to contextualize these in the working groups and expert groups that contributed to their development. So the RDM strategy template was put together by the Institutional Strategies Working Group, and it involves 4 main components: helping a document that would raise awareness on your campus, assess institutional readiness, formalize RDM practices, and define a roadmap, all with the potential of aiming toward an RDM policy for your campus. And associated with that is guidance. So there's a guidance document along with the template that would walk your committee through the process of building an RDM strategy for your campus. The second of these was data management planning, and it involved 3 of our expert groups. And it is the DMP Assistant, which is both a tool and a template. So the tool itself was installed and made ready to run by the University of Alberta independently, and they were offering it out to their researchers. They joined with Portage in offering this out nationally, and the Portage contribution to this was development of a Portage generic template. So guidance and, questions and sections and questions that a researcher would fill out. And they include these sections and 2 or 3 questions within each that researchers would fill out in an online form. And at the end of the day, they could push a button and export a data management plan. And if you're doing something fairly basic and you're familiar with your project and how you're doing it, I would say you could write one of these within about an hour. They are living documents. You do want to come back and revisit them because what you said at the beginning might not be what you would say midway and it might not be what you end up doing at the end. So they are living documents, but these are not that arduous to complete if you even have a notion of what you're doing. And if you don't have a notion of what you're doing, this kind of process is golden because it'll help you think about the things that you should be thinking about while you're doing a major project or even a minor project. And we have a new version of this coming along sometime in 2019. One of the pluses of this new system, among others, is that it will offer an opt-in to share. So it won't be assumed that you're going to share your DMP, but if you decide, yeah, my DMP is pretty cool, I like it, click, you're going to share, and at one point it would then be able to be shared out to other researchers as an exemplar within your discipline of a good DMP. Finally, we have national repository options, which is where we're going to spend most of the rest of our time. And these obviously took a lot more expert and working group involvement. And the 2 examples that we have are FERDR, the Federated Research Data Repository, and Dataverse. How many of you have heard of FERDR before? Okay, and Dataverse? Okay, so there's a little bit of awareness of these. These are 2 platforms that have been out for some time. Let's just take a look at these. Stepping back and looking at the Canadian repository landscape, we have general repositories, and these could include things like your institutional repository, where perhaps your published articles and such are being deposited. We have government repositories as well, such as Open Data Canada. Ontario has an open data portal. There are a lot of municipal open data portals, and there are domain-specific repositories as well. And I think there was one mentioned, Genome Canada, but there's also others for astronomy and a number of domain-specific repositories. If you want to find the right repository, one way of doing this is to use re3data.org, which is an index to repositories. And you can go in and say, I'm looking for stuff for biology, and it'll tell you which repositories are dealing with biology or geography or whatever. The benefits of data repositories, this is from the draft tri-agency policy. It will ensure safe storage, preservation, and curation of the data. Whenever possible, these data, metadata, and code should be linked to the publication with a persistent digital identifier. That's right from the draft policy. But the other benefits would be promoting best practices. The researcher would not ultimately be responsible for the ongoing stewardship of the research data in perpetuity. And so it speaks to the use case where I've had a head of a department who ran a lab, and his method was to he gave students I'll start with RIP, and then he gave students a tower, and they would do their work for the course of their graduate work. At the end of that time, he would rip that open, rip out the hard drive, slap their name on it, stick it on a shelf. That's how they dealt with their research data. Okay, I'm going to suggest to you that that is not a best practice, and that if you give it to a repository, they will handle that in perpetuity, and I think that's maybe a bit of a stretch for a repository, but we'll get going on that. It will increase discoverability and reusability, and again, I think as we move forward to this culture of getting credit for good data management, I think that will be a big help. And it does provide open or controlled access to research data without subscription or licensing fees associated with commercial publishers. So if we hand this all over to Elsevier or Springer, they're going to charge us back for access to their data because they'll do something value added that they say, oh, well, we have to charge you for this. and I don't think I'm telling you anything new there. So moving forward, we do have 2 national repository options being developed with and through Portage and partners. Further is being done in partnership with Compute Canada and offers in addition a national discovery service, which we'll talk about. And Dataverse is being developed as a national instance in partnership with the OCL Scholars Portal Dataverse team. And we'll look at each of these in turn. So what are the features of Further? And Further is not the best acronym in the world, but for the moment, that's what it is. But we get to say we go further and faster. Anyway, there it is. And for those of you who've heard that joke before, hey, get used to it. You're going to hear it every time I talk. Main features of Further are it's a national repository option that handles big data. One of the challenges of a lot of repositories, including currently Dataverse, is that they choke at about 2 gigabytes of upload. And that same thing applies to download. Try downloading half a terabyte of data from a repository, and sometimes they would not handle that. So you can upload and download big data from Further. It handles that through something called Globus File Transfer, I should say. It does maintain file hierarchies for upload and download, which is very important, because if you're uploading 1,000 files in a very distinct and useful file hierarchy, having them all go up as individual files and be an amorphous mass isn't terribly useful. And it's also scalable. It will handle large, it'll handle big. It's also a national discovery platform, and there is a preservation processing capacity being built for it as well. And we'll get into that later. It is currently in limited production, but I will say that the Global Water Futures Project is one of our partner institutions, and so their data is there as well. These are just some of the examples. Currently, we have 18 limited production partners, 52 data sets, published 4.2 terabytes of data, 32 data sets in progress, with 2.7 terabytes of data waiting. These are water-related. Yeah, I think this is tied. You know, if I told you from the outset how many slides I've got in my deck, you'd probably all leave the room. So, but you'll notice that I don't dwell on them very long. So if you want me to come back to something, I'm happy to do that. But it's like the 22 frames a second. You should see pretty much a movie if we keep going fast enough. So here we are with what we're doing now. And we are still inviting partners, and we're hoping to move into full production with some transition funding from ISED, which we're still in the process of talking about with them. Because money hasn't flowed yet. And an election is coming in 2019. And the clock is ticking. So there are a lot of stuff happening, a lot of moving pieces, folks, a lot of moving pieces. So Dataverse, what has it got? Its main features are it's a mature platform. It is Harvard-based open source software. It's widely adopted in Canada, the US, and around the world. It is very user-friendly for the researchers. And it is brandable, as you'll see in a moment. And it is a national repository option of note. These are the OCL partners that are members of the OCL Scholars Portal Dataverse. And we have instances of Dataverse elsewhere across the country, including Dalhousie, Alberta. There's a regional consortia out in the west called Abacus, and the University of New Brunswick has an instance of Dataverse as well. The question that we have to ask ourselves, and I'm not pushing this, we're not forcing anybody to do anything, but the question one must think about is does it make sense to have a variety of instances and potentially a variety of versions of Dataverse running across the country when we're hoping to have development happen with Dataverse for, let's say, geospatial discovery? How would that apply to version this and version that at two different, how would you deploy that? And would you want to have to deploy it in 2 places when if it was deployed in 1 place, it would be far more efficient? Anyway, all that to say, we're looking at this. If you're interested in joining Dataverse North, there is an email there for you. This slide deck will be provided to you in one form or another through Jay at the end of, after today. So we've been dealing with a lot of things with this tri-agency policy, the RDM strategy template, the DMP assistant, some repository options. But I'd like to look at this, another initiative of Portage before we go on, which sort of snuck by you earlier, and that is one of sensitive data. Sensitive data deals with intellectual property, as I think I mentioned earlier, in the context of the colleges, but also the universities. Indigenous data is certainly a major issue. There are financial concerns like commercial data. The geographer in the room, Antonio, you deal with Esri. You would not be able to deposit a shapefile from Esri into your local data repository because it's not yours to deposit. Environmental data can be very sensitive. Caribou, maybe not so much, but if you tell, I don't know, I keep picking on the birders. If you tell the birders where a certain bird is that's very rare, they will descend upon that space and, you know, in droves. And you, as one woman did, she started setting hours of operation for a hummingbird in her backyard that was a very rare hummingbird, and it was just bizarre. So sensitive data there, Facebook and other data breaches, and Europeans have something called the General Data Protection Regulation, which you might see variations of that moving through our legislative assembly at one point or other. So we have developed a working group, which I originally called the Ethics Working Group or the Sensitive Data Working Group. But when you convene 21 people working from various sectors within this, we immediately did what a committee always does, and that came up with something better. The Responsible Research Data Management Practices for Sensitive Data is what they wanted to call themselves. There is no acronym that we could even hope to squeeze out of that. So anyway, there it is. That's what we're called. And the things that we've decided to work on, and these are conscious decisions, and there are a raft of other things that we could have looked at. But we're looking at deposit-friendly text for ethics applications and for informed consent. Because if you don't get that right, you're not depositing your data. Data access agreements for data that is not appropriately meant to be facing public. Training materials, and we're working on that in concert with our training expert group. And an environmental scan of best practices for Indigenous data. And this is a huge issue and one that was alluded to earlier as well. Finally, looking at the development of RDM infrastructure in a broader context, we have a vision for federated RDM architecture that I've been just pushing out there to the community so that we're all sort of maybe speaking the same language. So what this vision involves is 3 levels of storage: active storage, repository storage, and archival or preservation storage. And if you understand what those are right now, then you can just sort of doze away for the rest of this, but we'll talk more about each of these. We're also thinking about these in the context of data management planning and curation. So our researchers, which I'll represent here by this map of Canada, and the fact that there are library consortia on this map is just an artifact of the image, but it's the researchers across Canada. They're working with active storage. And as I was talking with Roy earlier, active storage can be anything. It can be wherever you do your research. Once you've done your research and you've got it done, you'll want to move it under the policy into repository storage. And so that could be discipline-specific repositories, regional or institutional repositories, or instances of Dataverse, either at your institution or your region, or maybe a national version of Dataverse. In addition, you could decide to put your data into FERDR, which would handle big data if that's your use case, and it would handle upload and download. From there, there's this additional value add that FERDR is offering in gathering up or harvesting metadata from a lot of the repositories across Canada to create a national discovery layer. So what this does is brings metadata for the data sets housed in these repositories, currently over 40 of them, indexing over 90,000 data sets, all searchable in one place. Okay? Now, some of you may be saying, but Jeff, I saw that Google dataset search earlier, and that's true. The Google dataset search will do some of what this will do, but the Google dataset search is grabbing a very skeletal metadata record, and they haven't done much quality control on what it is they're grabbing, and they're indexing that. The folks who did this have harvested and normalized the metadata from each of these 40 repositories in a very systematic way, so that the quality of what you're able to search is going to be higher out of this search portal than it would be out of the Google dataset search. So FERDR's harvester makes research data held in many repositories discoverable from a single platform. It's bilingual, 40 repositories, and 90,000 metadata records. We have to recognize that metadata is not equal data. So in these instances, those projects that are working with us to deposit data in Furter, you go to Furter, you get the data and the metadata. For the harvesting and indexing, you're getting the metadata and you're getting a link out to the repository where the data are housed. So Furter is not pretending to be, you know, the one ring to rule them all. We'll have all your data. No, that's not the intent. The intent is to be a discovery layer to point people back and drive traffic to your home repository. The goals are to improve discovery of data, drive traffic to existing repositories, and break down silos. So awareness of data across disciplines is going to be very important going forward. So in addition to this, we have a preservation processing layer, which has archival storage as its label. And that preservation storage involves a fairly arcane process that you would probably not want to get into, but it does help to distinguish it from repository storage. Archival storage is a process where you decide that you're going to purposefully push your data through something called Archivematica to convert contents to future-friendly formats. So for example, a docx, which is a Word document, into a PDF-A, which is an archival PDF, and generation of archival information packages, which are then stored in a network of preservation storage providers. And if your eyes haven't glazed over by now, then you're a more techie guy than I am. The goal would be to have these stored in existing repositories that existing archival storage facilities that are purpose-built for storage over the long haul. So to bring all of this into context, I've built this data storage continuum, and it has active storage, which is controlled. It is a working copy short-term for the duration of your research, and its goal is to help you complete your research. The repository storage is open as appropriate. It's a dissemination copy meant for discovery and access. And archival storage is, again, open as appropriate, and it's a preservation copy for the long term, and it's for disaster recovery or copy of last resort. So looking at each of these in terms of examples, so active storage might be network drives, lab equipment, computers, potentially USB keys. I put that there because I know people use them. They may not be the best thing to use because they can get lost and so on. Cloud storage, nearline storage, which is something I'm very proud to say I now sort of pseudo-understand, which I did not 2 weeks ago, but this is a new addition to the slide. And nearline storage is where you'd have, online is fast-spinning, rapid access disks. Nearline is, and you're shaking your head no. You can tell me later what it is then. But that's the diagram I've got from somebody else, and they're smarter than I am. If the diagram tells you what it is, then I'll shut up and let the diagram speak, because words speak louder than, diagrams 1,000 words, right? Oh my goodness. High performance computing clusters, and I hope I've got that right, Roy. A bunch of computers bigger than your car. No, maybe not bigger than your car. Dealing with the high performance needs of people dealing with big data. And we've had some examples of big data mentioned earlier today by our panel. So active storage is supporting completion of research. Repository storage, we've gone over some of these examples already, and that would be repository storage supporting discovery and access. And finally, we have archival storage going through this process, which when the clicker works tells you that it's for long-term preservation of data over the long haul. And if you ask me about timeframes, we can talk about that later, but what we mean by each of these. Data storage continuum has a bunch of other things going on at the same time, so it is a useful way of framing the storage picture for RDM, but there are a lot of other things that happen, and the two other things that I want to flag here are data management planning and data curation. Curation is that decision-making process from the beginning to the end of what happens to your data. And so a curator would be deciding, this data is worth putting into long-term, and I'll say as well, expensive, long-term storage, the archival storage. So all of this can be described as good data stewardship. And then very quickly, portage outreach. We've been doing a lot of outreach ever since I started this job. My wife's lying to people asking, and how do you like this? She goes, well, he's home when he's home. And the rest of the time I'm out doing this. And so in January, February of last year, we did a 5-city, 18 presentation tour with the tri-agencies across the country. We did not get the T-shirt. They did not have the funding for that. We also reached out and did work across the country with regular consortial calls. So I have calls with each of the library consortia, like as we talk together. We've had webinars. I've had workshops with non-Carl libraries at Wilfrid Laurier and Lakehead. I've done, if the clicker was work, I've done a couple of things with College and Institutes Canada because they are concerned about this space as well. And we have regular calls with Canary on a number of committees. And the Canary RDM Fund, I think there was a mention of a fund here, one of the projects here at McMaster that got funded. There were 4 that were related specifically to RDM and had portage in-kind support. And each of these fits into this federated RDM architecture in sort of different places. We were kind of grateful to see that it wasn't concentrated in one location, but rather spread out across the spectrum. And we've been busy with a lot of other things as well. And in the interest of leaving time for questions, I think I will just say that we have a lot of partners and we're doing a lot of things and we want to be a part of this with you. And our goal is in the next steps is to build a community of data curators, and Jay, as the chair of our curation expert group, is going to be key in that. We want to add geospatial discovery features to Further and Dataverse. We're launching a number of training modules. We're improving tools for active storage, Further and Dataverse moving into national repository options. And this final one is transition to new organization under ISED funding. That's a picture that is still forming. More on that in another presentation. So we're doing a lot, more to come, and I'll take questions now. With 5 minutes. I was trying to go quicker, Jay. Got a question here?
I have a new question actually. First is, do you think you guys eventually can implement some AI in the area? And second thing is, how is the provincial government involved in this whole thing? Do you get any funding for this level or like that, or I'm just curious?
Okay, on your first question, AI, I will say that AI is a huge, how do I say this? AI has a huge appetite for data, okay? But that's not your question. Your question is, can some of this work be done in the context of AI? Could AI contribute to curation of data and so on? And I would suggest to you that I'd be stupid to say no. Is it happening right now? No, but the future holds a wealth of possibilities along this line. And I think that as we get clearer about what it is that we want as humans to achieve, it may be at that point that we can start saying, okay, we can get machines to do some of this work with us and for us. Regarding your provincial funding question, before ISED came back with a policy and the funding and how they're thinking about rolling out the funds, one of their major concerns was to go back and talk to the provinces, because they know that they're federal and they know that they're not alone in this. So they've gone out and talked to provincial agencies responsible for this issue across the country, and they've folded that advice, as far as I'm aware, into their as yet to be confirmed plan for the DRI landscape. And so the working assumption that I've been told about through a discussion paper that was not distributed broadly, but I can share the gist of it, is that there'll be RDM will be dealt with, there'll be a new organization created, or a new organization was floated that would include research data management, advanced research computing, and research software. And then there'd be another organization dealing with network and cybersecurity. And that's the kind of latest that I've heard, unless somebody's heard something more current from our funders, federal funders. But that's what I'm sort of working with, and there's been a lot of lobbying and toing and froing, and I'm hoping the next weeks and months, certainly in the new year, we'll hopefully hear more. Any other questions? Yes?
Has there been any thought to harvesting the data from non-Canadian repositories?
think I know that there are organizations out there like RDA, Research Data Alliance, which is an international, incredibly active organization that's only been in business for a decade or so, I'd say. And they, if you can believe it, run international conferences every 6 months. The last one was in Botswana maybe a month ago, and their next one's in Philadelphia. I think that they may be looking at this sort of an international discovery layer. Is that what you're saying? Sort of. Sure. Much the same way as Google isn't going out and grabbing the data, as far as we know. They're grabbing the metadata. Further does the same thing. Would there be anything stopping Further from harvesting metadata from another international archive? No, there'd be nothing stopping them from doing that. In fact, we're already doing that. The OCL Scholars Portal has a data portal called Odyssey. Anybody heard of Odyssey? Yeah, Odyssey is fantastic. I love it. It's the best thing going for social science research and survey data and all the rest. Well, they have Canadian data, Canadian polling data, Canadian census microdata files, but they also harvested data from the Canadian Opinion Research Archive. But that's Canadian, so that doesn't speak to your question. They also harvested the metadata from ICPSR, which is the largest social science and political research data archive in the world. So there are, 7,000, 8,000, 9,000 data sets represented in that Ann Arbor-based entity. That metadata is reflected in Odyssey and points back to the archive down in the States. So it's brilliant. So I think your idea is a good one. It's just, in limited production, we just haven't gotten to that point of looking that far down the road. But it does make sense. I don't think that Further, well, maybe Further is indexing Odyssey as well. It might be. But I was thinking more that the Further is harvesting from Dataverse, because Dataverse is a more natural home for research data. Odyssey is more naturally a home for, commercially produced polling data and StatsCan data. There's a blurring line there, and I think that, and I'm not saying for certain that Further doesn't have Odyssey data indexed, but either way, it's driving traffic to the place where the data is, and that's the important thing from my perspective. Yes?
I'm just curious to know, what's the involvement of health research in all of this? Because I didn't know what ISET was, so I just Googled it real quick. And I'm looking on the portfolio of all the agencies that are involved, and there's a noticeable nobody from CIHR is on here, Health Canada's not on here, only health-related one is Genome Canada. Is that just me, or?
There is no disciplinary restriction with the DRI. The DRI is pan-disciplinary. There's no question about that. And the tri-agencies themselves, as policy drivers in this, are hopefully covering off the majority, one way or another, covering off the majority of research disciplines with the three tri-agencies.
What's the DRI again?
Digital Research Infrastructure, under which RDM falls. The DRI is what got the money, and RDM is going to get a piece of that.
Right, and ISED?
ISED is Innovation, Science, and Economic Development Canada.
Yeah.
They run these enterprises. They run CFI, they fund the tri-agencies, they're these, I'm not an expert on what their actual place in the hierarchy is, but they fund the tri-agencies, they fund this, they fund other initiatives. So, yeah.
Well, thank you. I just wanted to clarify that, and I appreciate your insight.
And we have to be careful with acronyms.
I know, right?
because, and you can pick an acronym with the best of intentions. How many people know about the Institute for Clinical and Evaluative Sciences? What a sad day that was when it became clear that that acronym was not a very good one because it's pronounced ISIS. But anyway, leaving that aside, J is standing, which means I'm probably sitting, and your lunch is ready to rock and roll. So.
Thanks, Jeff. So before doing the final thank you to Jeff, just a couple more logistical things. So this concludes the morning sessions, and we're going to have a lunch until 1 o'clock. For those of you who have signed up for the afternoon workshop, that'll take place here. So we've had to move it to this space due to overwhelming demand, which is a great problem to have. So please excuse if there's some tables moving around while you're trying to eat your lunch. And so with that, I'm going to close this off by extending a heartfelt thank you to Jeff for coming here today. Jeff, you know, as he talked about, he's been doing this roadshow for quite a while, and we really appreciate you and your wife's understanding to have you come here and talk with us. So thank you. Thanks, Jeff. So I think lunch is served.